Now let's use an example to see how the second law of thermodynamics is used to predict the spontaneity of a process. Let's read the problem together. Predict the spontaneity of the following processes based on the second law of thermodynamics. The enthalpy of furan and entropy of furan are: enthalpy of furan is 6.02 kJ per mole and entropy of furan is 22.05 joule per mole per Kelvin respectively, and assume that they are independent of temperature. A. Ice melts to water at 25 degrees Celsius and 1 atmospheric pressure. From the second law of thermodynamics, if delta S total is positive, the process is spontaneous. Let me put it down. To get delta S total, we have to know delta S system and delta S surroundings. In this case, ice and water is what we are interested in. Therefore, they are defined as the system. Everything else is defined as the surroundings. Therefore, delta S system should be equal to delta S furan. To calculate delta S surroundings, we have to use the definition of delta S. By definition, delta S surroundings is equal to Q reversible of the surroundings over the temperature of the surroundings. Reversible means the heat must be the heat of a reversible process. Surroundings means the heat is the heat of the surroundings. If there's no heat loss during this process, the Q system should be equal to negative Q surroundings. The Q system is the heat at constant pressure of the system should be equal to delta H of the system. Therefore, Q system is Q furan is delta H furan. Then we combine all this together. We will get delta S surroundings is equal to negative delta H furan over T surroundings. Apparently, you can plug all numbers from this problem into these equations to figure out the answer step by step. Another way to do this is we will get a new formula and then we plug in all the numbers at the end. Let's try that. We can use delta S total to predict the spontaneous direction. Actually, we can also use the top term, delta H furan minus T surroundings times delta S furan to predict. If delta S total is positive, then the top term should be negative. In other words, if the top term is negative, the process is spontaneous. But compared to delta S total, we can use the system parameters plus the temperature of the surroundings to predict the spontaneous direction. To use the system parameters is more convenient than to calculate the two parts. Therefore, we define a new term which we call delta G furan. In more general terms, we should call this delta G system. If we use this term, we know that delta G furan is equal to delta H furan minus T surroundings times delta S furan. Generally, we can omit these subscripts. Delta H, delta S are system parameters. Let me put down the more general term. As I said, you can use delta S total to predict the spontaneous direction. You can also use delta G to predict the spontaneous direction. let me put it down how to use delta G to predict the spontaneous direction. Let me summarize. If you use a term like this one again, it is better to define a new term and give a new name. This is a common practice when you do science. I hope whenever you encounter your own problem, you define your own terms. Well, then, how do we calculate? The answer for A, I think you don't need my help to do the calculations. But still, let me plug in the numbers to help you to get your answer. You have to convert this to joules, so the units of delta H and delta S will match. Well, let me check. Then you plug all numbers into a calculator, you will get the answer. This is positive. Therefore, this is a spontaneous process. It agrees with our experience. Above the melting point from ice to water is a spontaneous process.